as far as terms, we're talking about dimension. What dimension are we in when we're talking perimeter? We're in one dimension. What's a unit that measures perimeter or length?
Feet.
What? Feet. What's another one? Meters. What's another one? Inches. Yards. These are all one-dimensional measurements. We can measure from here to you. That's one dimension. That's it. One dimensional. If we lay all this perimeter down, it's just a straight line, and we can measure from one point to another point. That's all we can really measure. Now, area is a little bit different. How do we measure area?
Square.
Two dimensions. We have square feet, or square meters, or square yards, or square centimeters. The difference here is the units. Perimeter is measured in regular units, and area is measured in what? Not regular units.
Units squared.
Units squared. Okay? That's a big deal because in a second on your homework you'll have some questions that you have to do. Measurements of perimeter and area. You've got to make sure you have those units labeled correctly.
On the test, are you ever going to ask us like the difference between perimeter and area?
No, not that easy. But I will ask you to find the perimeter or shape, just like I'm going to do here. Someone give me their favorite letter.
E.
E. Okay, someone give me another one.
L.
Z.
E and Z. These are the measurements of this shape. So, I want to know the perimeter of this shape. What's the perimeter?
E times E. Oh, jeez.
Perimeter, I want to know the
Sorry.
perimeter.
Sorry.
E plus Z plus E plus Z. No, the whole perimeter is 2E plus 2Z. Are we good with that? Okay. What's wrong? I kind of messed this up. I need units here. Because we're in one dimension, we're measuring perimeter. Okay? Now, what if I wanted to find the area? Same thing, E and Z. What's the area of this shape?
E squared times Z squared.
Be careful. Area of a rectangle is going to give you length times width.
Times height. Oh.
Width times height will work as well. So this would just be E times Z. What's the area? EZ. Love it.
Easy.
What's different? Units squared. Okay? That's what you're doing on your homework a little bit. Let's do a little bit more advanced problem here. I've got one built into this little presentation here. Not with E's and Z's. With some real terminology here. Okay, so we're going to do these because we're running out of time. We got to cover one more thing. I'm going to do these together real quickly. These are in your booklet on page 13. First one up there, I'm looking for the perimeter of the triangle. What am I going to do when I'm trying to find the perimeter?
Base times height.
Perimeter.
Oh, my God.
I'm just going to add all the sides. So I've got three sides here. I'm just going to add them. I'm going to write them all down. 3x squared minus 4x plus 9 plus 2x squared plus 4x minus 10 plus 5x plus 3. Is that a 4? Which one? That's a 4, yes. Now, combining like terms, I've got 3x squared, 2x squareds, 5x squareds. I'm going to switch up colors for my x terms. I've got a negative 4x, a positive 4x, and then positive 5x. Negative 4, positive 4 go away. I'm left with a positive 5x. And then my numerical terms, plus 9, minus 10, that's minus 1, plus 3 is going to be plus 2. My answer is 5x squared plus 5x plus 2 units for the perimeter. Okay? I'm going quickly, I know that. There's one more big thing we need to touch on before we move on. This next one, number 2, I'm not going to solve. I'm going to set up the expression. So what I'm looking for is I'm looking for the area of this shaded space. What's cool here is I've got the measurements of those two sides of the square, and it tells you in instructions here that this interior box
Is X by X?
is x by x. So, what in the world could we do?
Find out first multiply 2x negative 5, right?
So if we multiply 2x minus 5 times 2x minus 5, what have we done?
You found the whole area.
We've multiplied this side by this side. We found the area of the entire shape. We want the area of the entire shape. No, we want to take off what?
X squared.
This blue area, right? We've got to subtract or get rid of this blue area. How do we find the area of that? Subtract off x times x. Sorry? Yeah, it probably should. It probably should. Foiling this, you can write down the answer if you'd like and then work it out on your own in a minute. 4x squared minus 10x minus 10x plus 25 minus x squared. So the final answer is going to be 3x squared minus 20x plus 25. I'm not done yet. Because I'm in 2 dimensions, I've got to look at units squared. This unit squared thing is kind of a little ridiculous at this point, but it's going to make things easier in about 2 weeks. So stick with me on that. Okay? We're getting the idea of these problems? Okay? All you're doing now, we don't have a value for x, we don't have an equal sign. So all you can do is simplify this equation. You can't do anything else. Okay? You can't do anything else. We'll do more about that in a little bit. Now the last section on your homework is going to be related to problems like this one from earlier. Yeah, I can't do any of these. Oh, I was going to do 2 more examples. We're not going to. Okay. So the last stuff we're talking about tonight, greatest common factor. Tell me what you remember about those words, greatest common factor.
Remember that could go in like something you can take out of.
Yeah, it's something you can take out of multiple things. So if I look at 12, the factors of 12 are 1 and 12, 3 and 4, 2 and 6. Those are all different factors. Okay? You might have seen this done in class before with a factor tree. Here are 2 factor trees where you've got 2 terms, 48 and 24, and I just broke it down into its factors. Side note, what are these little things in the boxes?
Prime numbers.
Prime numbers, you can't break those down anymore. Okay? Now what's cool is we can look at factors of polynomials. So the polynomial from earlier, 6a cubed plus 2a, they have a common factor there. This is going to be very important language because we're going to talk about this a lot this semester. And these have something in common that you can pull out, or you can rewrite this expression differently.
12.
2. Now 12, be careful. 12, I can see why some of you would say 12, because 6 times 2 is 12, and 2 times 6 is 12. Meaning, this can go into 12, and this can go into 12. But 12 is not a factor. 12 is what we call a multiple, because it can go up to 12. But we don't care about multiples right now. We care about a factor.
It'd be 2a.
So, some people are saying 2a. How are you getting that?
Because it'll come out of the 2, and then the 6 as well. You can pull a 2 definitely out from both, but if you pulled out the a, then it would just be 6a to the 2, and then plus 1.
So let's just jump to what you said, and then we'll talk about why it makes sense. So we're going to pull a 2a out of both terms. So if we pull a 2a out of 6a cubed, we're left with a 3a squared. If you want to check me, just distribute that again. What's 2a times 3a squared? Well, 2 times 3 is 6. A times a squared is a cubed. So that checks out. Now, if we pull a 2a out of 2a, what are we left with?
1.
Just a 1. So this expression here can be really rewritten in the most simplified terms on the bottom step, with the greatest common factor pulled out.
Did you also take out the 6?
You can't pull out a 6a squared because there's not a 6 there. They don't have a 6. One way to think about this is take your polynomial and do the trees like you did before. So this tree, 6a cubed plus 2a. Well, what does this 6a have in it? It has a 2 and a 3a cubed. You can't take that 2 any further. You can take this as 3 2a cubed. You can't take that 3 anymore. And then this a cubed is really a times a times a. So that's the prime factorization of that monomial. This 2a can be split up into 2 times a. So the things they have in common here, they have a 2 in common and an a in common. So you can pull out a 2a. Okay? The greatest common factor of that term is a 2a. So you've got 2 parts of your homework. One part, what did you say?
I've never done it with like cube.
Never done that before, right?
Yeah.
Totally new. This is actually the beginning of college. No, technically this is not college yet, but we're getting there. We're getting close. Hold on. Gotcha. Thank you. Let's give me another example. Someone give me a polynomial. Love it. 3x squared. Someone give me another polynomial. Or another monomial. Or something. 3x? 3x that works. Minus 3x. Can you pull the greatest common factor out of that?
3.
You can pull a 3 out. I agree. Can you pull anything else out? You can also pull an x out. If you pull a 3x out, what are you left with the first term?
X.
Just an x. What are you left with the second term?
1.
Just a 1. Nice job. Another little example there. What I'd like for us to do, everyone, we're going to solve, we're going to practice 1 or 2 of these. Pick the level that you feel good with. Red if you're really lost. Green if you want to be challenged. And yellow if you want to try something in the middle. I'll put the answers over here on the right-hand side. Is there an easier one? You can try number 1. It's a little easier. Once you get the answer of 4, come up here and write it up here, because I don't want to do it.
The answer for 4?
Yeah, go up there and write it on the board, because I don't want to. You can do whatever number you want. I'm just saying. Which one do you work on? I would separate 3 times that.
For number 5, you just take out by 6x squared and you take out y.
But how would you? You said 4x how would you pull an x out?
Oh, you're right. It can't be 4. So that's be 4y squared. Just 4 going. Yeah, it's 4y squared.
So that 16 isn't attached to just the x, it's attached to the y too.
Good. Yes, it is. That 16 is attached to the x squared and the y squared. How are we doing? All right. Okay.
So what do these have in common? 2? They're both of the 2? What else do they have? They're both of the 3.
So you can pull that. That's going to go on the outside. Okay, so do that.
Just start from that.
can't take it out of X. What you're going to take out is you're going to take out the y squared. Not just the y squared, something else.
4y squared.
4y squared. So when you do that, you got 3 things left over. I don't know what they are, but.
Okay, that's all I did. I just
Nice job.
No, actually, you're like when you
Wait, can I write it?
Remember that back there? Back there? Keep going. Okay.